Hello students, welcome back to the session, grade 10, chapter number 12, electricity, and this is the last part. D, A, B, C have been uploaded in the channel. You can cross check and go through it. If any doubts, you can use the comment section or the WhatsApp numbers are given. So in part D, what are we going to discuss? We are going to discuss about the heating effect of electric current, electric power and electrical energy. We will discuss about heating effect of electric current, electric power and electrical energy. So what is this heating effect of electric current? So when electric current passes through a conductor, what will happen? Electrical energy is converted into heat energy. Can you please imagine the examples? When electric current is passing through a conductor, the electrical energy is converted into heat energy. The geyser, the electric stove, the ironing clothes, you pass electricity, the electrical energy you give, it will convert into heat energy. So this phenomena is known as heating effect of electric current. Next comes your Joule's law of heating. So whenever the heat is produced, where the heat is produced in a conductor, which is always directly proportional to the square of the current. The heat is produced will be directly proportional to the square of the current. Heat produced is directly proportional to the resistance, and heat produced will be directly proportional to the time for which the current flows. If you are passing the current for 5 minutes, and if you are passing the current for 1 minute, so in which scenario the heat will be produced more? As time duration is more, heat produced will be more. So Joule's law is given by Q is equal to I square RT. Joule's law is given by the formula Q is equal to I square RT, where Q will indicate the amount of heat, I shows electric current, R is the amount of electric resistance in the conductor, and T will represent the time. So the practical applications of heating effect. The heating effect of electric current is used in, as we discussed earlier regarding the examples, electric iron, electric heater, electric kettle, toaster, geyser, electric fuse. The heating effect of electric current is used in electric iron, electric heater, electric kettle, toaster, geyser, electric fuse. The above ones are all similar to you. The electric fuse. What is an electric fuse? It is a safety device which will melt when excessive current will flow. It is a safety device. When more amount of current is flowing through a circuit, it will protect the electrical appliances from the damage. This is a figure. This fuse wire gets heated up and it gets disconnected. If it's disconnected, the current supply will stop. So you can check by the damage done over here in the fuse wire. Damage done means the wire will be burnt. You can remove it, clean it, and again you can fix a small wire, and when you fix it again it reboots and the current flows automatically. Next comes electric power. Electric power is the rate at which electrical energy is consumed or converted into other forms of energy. What is electric power? The rate in the given time, how much electrical energy is consumed, how much electrical energy is consumed or converted into another forms of energy. So how much time did you supply the current, and what happened is the electrical energy has been converted into any other forms. Here you have the formula for electric power. P equal to V times R, which will be is equal to I square R, which will be equal to V square over R. P is electric power, watts, W is the unit, R is the resistance, ohms, V is the voltage difference, and I is the electric current, amperes. The SI unit as discussed is watt. So how you are going to define 1 watt? 1 watt is the power consumed when 1 joule of work is done. So when you are doing 1 joule of work, will you consume some time? How much time did you consume? 1 second. So 1 watt is the power consumed when you are doing a 1 joule of work in 1 second is known as 1 watt. Electrical energy, the total electrical work done or energy consumed by electrical appliances. How much amount of electrical energy is being consumed by an electrical appliance is called electrical energy. And the electrical energy is given by the formula E equal to P times T. You can use the magic triangle where E is the energy always in joules, P is power in watts, and T time in seconds. E equal to P times T, or P equal to E over T, or T equal to E over P. Commercial unit of how you are going to measure the how much amount of electrical energy has been used. It is measured by the unit called 1 kWh, 1 kilowatt hour. 1 kilowatt hour is known as 1 unit. You can convert kilowatt hour into joule. 1 kilowatt hour equal to 1 kilowatt into 1 hour. Kilo means 1000 watts into in 1 hour you have 3600 seconds. So 1000 into 3600 seconds you can write in the standard form. So 1 kWh will be is equal to 3.6 into 10 to the power of 6 joules. So related to that we have some numericals. Here you have a bulb of 100 watts is used for 5 hours. What you need to find? You need to find the electrical energy consumed. Write down the given. Power is 100 watts and time is 5 hours. So energy E equal to P times T. Always remember the unit watt hour only. So no need to convert in seconds over here. So 100 times 5 is 500 watt hour. Convert into kilo divided by 1000. So energy will be is equal to 0.5 kilowatt hour. Second numerical. You have a resistor of 10 ohms which is carrying 2 amperes current for 5 minutes. A resistor of 10 ohms carries a 2 ampere current. How much time? For 5 minutes. How much is the heat produced? Earlier we have discussed the heat formula. After writing the given from the question, I is 2 amperes, R is 10 ohms and T is 5 minutes. Convert into seconds. 300 seconds. 5 times 60. So H will be equal to I square RT. Put the values over here. You will get the heat will be released is produced is 12,000 joules. Next, electric bulb operates at 220 volts and draws 0.5 amperes. Calculate its power. Solution P equal to V times I. So P is 220 and I is 0.5 amperes. So 220 times 0.5, P is 110 over here and the unit of power is watts. So power will be equal to 110 watts. These are the entire chapter formulas. For your reference we have given it and the notes will be given in the description box. Any doubts, any queries, you can please contact to the given WhatsApp numbers or you can mention in the comment box, students. Thank you very much, students. Bye bye, take care.